Sejahtera to everyone. Could anyone respond whether you receive my voice loud, loud and clear? Yes, thank you. Thank you, Aisha. Thank you, everyone. As for today, 28th of November 2021, equivalent to 23rd of Rabiul Akhir 1443 Hijriah, class start at 8 to 10, 2 hours class, and we are going to talk about the continuation of the balancing of the reciprocating mass, typically talking about the engine, and today we're going to talk about the inline engine. So I'm going to stop sharing this one. I'm going to share with you another file so that I can write something on it. This one, yeah. So before we pursue this one, as usual, I'm going to perhaps share with you or we capture the thing that we study last meeting, yeah, in the last meeting. So what I intend to share with you is the whole thing that we are going to talk about, until the what do you call it, the solution or the example, how to solve the problem. So I'm going to start with this one just to recapture the thing here so that you can refresh the thing we studied earlier. Yeah. Okay. So we are basically talking about the inline engine. And of course, our aims now is to check whether the engine typically balanced or not. And we are going to focus on the inline engine first. The next couple of lecture, we are going to look in another type of engine, which is start with the what do you call it, the radial engine, and also the V engine. Someone asking about the Google form. I think the Google form already automated. Yeah, activate at it typically 2 or 3 minutes before class start. So already on the Google form, that one is automatically generated at 2 or 3 minutes. So everyone can fill in the Google form, and also in the the chat session to ensure that you are basically in this session. Okay, I'm going to use my blank template here to basically discuss about things that we already discussed. Okay, now, so we are basically in the middle of a discussion on the reciprocating mass. Rotating of a reciprocating mass. This one is reciprocating mass. Before I start this one, yeah, I'm going to basically remind you. You will have your test today, your mock-up test, your mock test. Your mock test will be you can submit before 11 p.m. I will give you inshallah 1 or 2 sets immediately or perhaps in the late afternoon today. Okay, the reciprocating mass. Of course, we are talking about balancing. Yeah, this one is balancing. You have couple of things here. Okay, start with inline engine. Inline engine. Then we move to the radial engine, which is more challenging. Yeah, radial engine, and then last one is the V engine. And this V engine and inline engine will have similar solution, or if not the solution, we can put a step of solutions. Step of solution. The inline engine, this one will base on type of engine. Okay, will be based on type of engine. So you have two type of engine, typically the 2-stroke engine and also the 4-stroke engine. Okay, so from the very beginning, I did mention about first you have to know what be the unbalanced force of the reciprocating, or let's put it the internal combustion engine. So the unbalanced force we already done earlier is equal to, we have the m omega square cos theta plus the m omega square cos 2 theta divided by n. and this n is equal to L divided by R. L will be the connecting one, the length of connecting one, R will be the radius of crank or crank radius, and the L, the small L here, is equal to twice of the radius. Okay, so from this equation, you know that you have two terms of equation. This one. So this one we call it as F primary is equal to M omega square R cos theta. This one we call this one as F secondary is equal to M R omega square cos theta divided by. Okay, so you have another one because you're talking about multi-cylinder, for example. So you have this M unbalanced. This one will be exactly the same here. You will have MRD omega square. Sometimes I put R, in front. Sometimes I put R together with MR, doesn't matter, yeah. So MRD omega square, this one cos theta plus this one be MRD omega square cos 2 theta divided by again N. And here you have yeah, you have two part, again two part of equation. This one and this one. We call this one as MS, isn't it? MS will be what? What is your MS? Is the sorry, it's MS, not MS, sorry. MP, MS, sorry, yeah. It's MP, the primary couple. Sometimes M can also known as moment sometime couple. So your M primary is equal to the MRD omega square cos theta. Here we call it is M secondary. You will have this one MRD omega square cos 2 theta divided by N. So if you look at very careful, you have 1, you have 2, you have 3 here, and finally you have 4. So you have 4 equations. So solution will deal with what? 4 polygons. Okay, 4 polygons. Of course, if you want to do by analytical, you have 4 major, and how come you can write it? 4 major equation. 4 major. Stop margin. 4 major, MAJOR, major equation. Okay, so I'm going to talk about what is the polygon at the moment. Yeah, so the polygon will be the polygon. You have what? One will be what you call as the false polygon, primary false. Then you have primary couple. This one you have another one, secondary false. Then you have secondary couple. You have 4. This one of course versus theta versus VS, yeah, versus 2 theta because sorry, both are versus 2 theta. Sorry, I stopped mounting. This one is versus also theta. This one secondary will versus 2 theta. This one versus 2 theta. Okay, so this is very important, the 2 equation. So because the equation, comprising of theta here, look at here, you have theta, r theta, n, okay, clear. And you know this one, n. So you need to know what theta is. So we need to know or perhaps define what is theta. So theta is crank position. Okay, crank position. Okay, so we have two type of this one depends on type of engine, depends on the engine. So what you have, remember theta is equal to 360 divided by n. This one for two-stroke engine, where your n equal to number of cylinder. Right? The other one is we have theta 720 divided by n. This is the four-stroke engine, and again is equal to is belong to or represent the number of cylinder. So when you understand this one, then only the next thing will be very simple. So then we start with, remember we start with construct one crank crank diagram. This one, yeah, this one is compulsory. Put it there, compulsory. It's a must. Okay, so before you construct that crank diagram, so before do this one, do this, you need to know what do you need to know? Remember, anyone? What do you need to know before you construct the crank diagram, class? Anyone? Anyone? I think everyone attended the lecture last week. It is not very fun, only last week, isn't it? Yes, correct, Dan. Is you need to know FO, firing order. Again, firing order also compulsory. You need to know, you need to know compulsory. If there's no firing order, for example, then you have to what? You have to design your own firing order. How to design? I will, discuss or share with you later on. Yeah. Okay. Now, so what is firing order? Firing order is basically the sequential of power being delivered. Sequential means you have four activities. What are the activity? The activities, this one for activity internal combustion engine. Yeah, what are the activity? One be the induction, some would call suction, is the same, isn't it? This one number one. Number two is what? After induction, one is a combustion, or what? Could anyone tell me what you have after induction? Anyone? If you don't want to answer this one, I leave it like that, and then you have to check on your own this one. So what do you have after induction? Compression or combustion. Yeah, okay. Compression is correct, combustion also correct. Huh? Number three. Then this one, ignition or firing. Then number four, this one. Then you have what? Power. Oh, sorry, ignition or power. This one, exhaust. This one is combustion. This one is exhaust. EXHAUS, exhaust. Okay, so these are the four activity in the internal combustion engine. So you already know what is firing order. So who decide the firing order? The engineer, or perhaps the person who designed the engine is the one in charge, or perhaps the one is responsible to decide the firing order. Okay, now then we start to what I'm going to share with you now is how to construct crank diagram, because this is very important. Okay, let's assume you have, we go back to your notes. Let's assume you have that everything that I explained here is in your notes. Yeah, don't bother if you don't copy, it's still okay. Then just check on your notes. Yeah, let's assume that you have as such. You have this one on page in your slide, yeah, in your slide 27, 28, 20, 31, this one. We have 4 slides in one page because I tried to give you one page for one. A file is it can't make it because so huge, and the file is so huge. So you have this one. So this is by firing order. So assuming this one, let's assume you have 2-stroke. Yeah, let's assume this is the given 2-stroke engine. Sorry, 2-stroke 4-cylinder engine. Firing order 1, 2, 3, 4. Don't bother about the firing order, because this firing order is given. Or it's not given, then you design. How to design? I will explain to you later. So we have 2-stroke 4-cylinder go here. So you have 2-stroke engine with 4-cylinder. So what you have, theta now is equal to 2-stroke 360 divided by 4. You will have 90 degrees. So what does this mean? Yeah, it simply means that if you have 4-cylinder, so cylinder number 1, cylinder number 2, cylinder number 3, cylinder number 4, the arrangement will be 0, because let's assume the arrangement be 0 here, 90 here, 180. This one is 270. Clockwise from the horizontal, sorry, from the vertical, you have 0. The next one is 90, isn't it? So you have this one 90. The next one be what you have 180. The next one what you have here 270. Am I correct or not? Yes or no? Yes or no? So that is the arrangement. That will be the arrangement. But this one is based on the crank. Based on the crank. So the position will be as such. This one, look at here, 90. Correct? This one, 0 degrees, 90. This one is 180. This one is 270. If you look at from one end here, you will have this one. 1, 2, 3, 4. Am I correct? 1, 2, 3, 4. So that will be the arrangement. So it's rotating clockwise. Why this one is very our concern? Remember when I show you the firing order, you need to know what be the direction. So let's go back to the firing order. If some of you might not observe about the firing order, so I'm going to share with you about the firing order. I'm going to open up the file. I'm going to share with you the direction for the firing order. Remember, so that is very important to know where will be the direction. If the direction is not been given, for example, yeah, you need to decide on your own. So, for example, this one, this is the direction of firing order. Can you see this one, class? This is rotating clockwise from your seat. Can you see? So this is the direction. Yes or no?
Yes, doctor.
Okay, look at here. This one also clockwise, the other one counter. So this is the direction. So the direction must be given. If it is not provided in the in the equation, for example, you have to make your own adjustment. Yeah. So I'm going to close this file. I'm going to open up the other file just now, so I can write on it. Yeah, this one. Okay, now. So perhaps, yeah, it mentioned about rotating counterclockwise from your seat. So this will be the arrangement. The arrangement is 1, 2, 3, 4. Okay, so we go back to here. So supposingly, so this one, so you will have, okay, the crank. This one, yeah, somehow or other, you know that the firing order also exactly the same. 1, 2, 3, and 4. So you have the same results. You will have the same result. This one, the firing order, yeah. So if you start with here 0, this one will be 90, this one will be 180, this one will be 270. So you can also put notation or put sign on your crank diagram. Is 1, 2, 3, 4, rotating counterclockwise from your seats. So my equation. So this is my equation now. Supposingly I change the omega. I'm gonna put it here. 1, 2, 3, 4 just now. This one. Could anyone tell me what will be the firing order now? Now I'll change the direction. So could anyone tell me? So what will be your firing order now? Anyone? Anyone? So this one, this will be fine order. If you have this one, for example, because I change the direction now. So what will be the fine order now? Anyone? Could anyone? 4, 3, 1, 4, 1, 4, 3, 2 is correct. Yeah, it's 1 here, isn't it? Then this one to 4. Oops, sorry. I say 4, but I write 3. Sorry, guys. This one here 4, correct? The next one coming 3. The next one coming 2. Okay, it's still 90 degrees, isn't it? It's still 90 degrees, 90. So this one 90 degrees, 90 degrees, 90 degrees. Okay. So it is not very difficult. It is not very difficult. So if you construct, for example, this one not in our discussion, let's focusing on this one because this is not in your note. It is correct, but not in your notes. Your note tell you about this one. So if you have this one as such just now, 1, 2, 3, 4, rotating that way. So if you construct polygon, for example, you construct polygon, what do you have now? Of course, it is balanced. It is balanced, correct? So if you construct a polygon, so what do you have? You will have, okay, 1 here pointing upward, 1, 2 will be moving that way, 2, 3 will be pointing downward, and 4 will be pointing at 1. You will have a very nice square, isn't it? Or perhaps you can also have another parameter if you want to do this. You can also have another parameter. So it's up to you how do you construct the polygons. Okay, it's not very difficult, isn't it? So now my question is, does polygon compulsory? Yes, compulsory to construct. It is compulsory to construct even though it is balanced. It is balanced, you can construct by freehand. You don't have to measure. But if it's not balanced, you have to do measurement or you can do calculation. Okay. Now I'm going to move to another one. Any question up to here? So what is the crank? We are in the middle of discussion about crank diagram. It's crank diagram. We don't have any motive at the moment, just to check whether balance or not balance or not balance. So these are our aims now. This one balance. Okay, so you go to another one. So this time around, you have what? You have 4-stroke engine and 4-cylinder. Okay, 4-stroke engine, 4-cylinder. We go back to here. The next one, you have 4-stroke engine. Let me change the color here. So you have 4-stroke engine with 4-cylinder. So the theta now is given by 720 by 4. So you will have 180. What does this mean? If the firing order given here, what does the firing order now? It gives us 1, 3, 4, 2, for example. It's 1, 3, 4, 2. If you are pointing, or perhaps your reference is 0 here, 90 here, 180 here, and this one is 270, you are basically saying that you have 1, 180, you have 0, another 180. Am I correct or not? Or you can also put in another manner that you have 1, 180, this one is 360, correct? Then you have that 160, 185, 40. Yes or no? So how is the arrangement then? So the arrangement will be the polygon. Oh, sorry, it's not polygon. The crank diagram is not the polygon yet. Yeah, it's crank diagram. So the crank diagram will be 1 minute. Yeah. Let me change another color here. Okay. So the crank diagram will be crank diagram now. So how is it? You have crank diagram. Okay. Then you have one will be here. So you have, okay, put it here. Zap here. This one 1, your reference just now. This one is 90, right? So put it your reference now. 0, 90, 180, 270. So you have 1, 180, 360, 540. So you have 2, you have 3, sorry, you have to follow the firing order. So the firing order gives us what? 1, 3, 4, 2. So this one is 1, 3, 4. Correct or not? Correct or not? And it's rotating what? Oh, so when will be the rotation now? So that is important. So when will be the rotation now? Clockwise or counterclockwise? Clockwise or counterclockwise, class? Clockwise or counterclockwise? 1, 3. My order is 1, 3, 4. So clockwise or counterclockwise? Hello? Anyone? No one interested to answer. So does it rotating clockwise or counterclockwise? Counterclockwise, correct. This one is omega. Put it there, omega. Okay. Okay, now finish. Yeah. Let us now focus on this one. So how will be the position for the actual engine, yeah, or the position, I mean the crank, yeah. So you are looking for one end here, so your eyes is here. Let's put it a bit thicker. Yeah. So if you look at this, so you found this one is 0 degrees, isn't it? So the next one is what? The next one is 3 here. The next one is 4 here, isn't it? The next one is, okay, so 2 and 3, 1 and 4. Does it balance? Yes, it is balanced. Yes. So if it is balanced, so your polygon will be, how will be your polygon? We can start here. How will be your polygon? Your polygon will be 1, zap, start in the middle here, isn't it? Then number 1, then you have two choices. Let's say you have two choices. You can put here 1, quite a bit longer, yeah. 1, then you have another one, 4. So then what you have is the 3 will be pointing downward, 2 will be pointing downward, and it is balanced. Put it there, balance. Or it can also be, in the form of, starting point 1, 1, then is 4, 4, then is 3, then is, okay. So now my advice is also balance. But to ensure that the one who check your work is basically understand what you're doing, so don't do this one. So don't do this one. The reason is what, the minute you keep doing this one on the same line, this one, yeah, in the same line. So after all, if you have 20 cylinder, for example, your paper will tear, isn't it? Will tear. Huh? So what you have to do now is, so this one. So this one is the correct. I'm not saying this one is the what, the appropriate, appropriate polygons. It is correct. I'm not saying this one is not correct. Yeah, it is correct. It is correct. But the one to check your work is very what, looks so messy here. If you're 16 cylinder, for example, so the appropriate polygon will be, you have this one. Okay, starting. Uh, just now, what's number 1, number 4, then put it here, number 3, number. Even though you know that these two lines are overlapping or perhaps superimposed to each other, yeah, you have to create, for example, to ensure that the one who correct your work is understand. Okay, so, or perhaps you can also do this one, another possibility. 1, the next one will be 3, the next one, go back here, number 4, the next one this number. So this one, both are, so you can choose in either one. It is called polygons. Yeah, it is called polygon. This polygon is not what you will learn in your secondary school. No, the polygon you learn in secondary school is what? What does the teacher tell you? Polygon must be at least what? What do you know about polygon? Terminology. What do you understand by polygon? Anyone? I don't want you asking, hey, is this basically not polygon? Can anyone tell me in the terminology, what does polygon tell you? At least what? You must have what? Three what? You must have three. You must have three line. That is a polygon, isn't it? You at least you have three line. For example, this one, this is polygon. This one only have only one line. One go up and one go down. It's not polygon. But in engineering perspective, balancing typically, this is called polygon. This is not the polygon you learn in your secondary school or your formal institution. This is talking about the balancing. It is not exactly the polygon in the terminology. It's basically the polygon representing a crank to decide whether it's balanced or not. Understand me or not, class? Okay. Okay. Let's pick up. Anyone can respond? You understand or not in the moment? So can so that I can easily or perhaps happy to proceed. Yes, thank you, Ko. Okay, now let us now move to the next one, which is more challenging. This one, is nothing much. Yeah, this one you can put this one in the form of table. So this one just to share with you how to construct the crank diagram. So now I'm going to construct this one again, but applying the primary and secondary. Applying the primary and secondary. Okay, don't go to this one first. I'm going to share with you this one. What happens primary and secondary. Okay, now start here. Yeah. So what you have here? Listen up very careful. This one. We have two-stroke engine. Okay, two-stroke, four-cylinder. We already calculated theta is equal to just now is 360 divided by n, and this one is 360 by 4. It gives you 90. And the firing order, this one they provide us 1, 2, 3, and 4 firing order. So you know that this one all 90 degrees. And let's say the position is this one. Okay, so how do you construct? So the crank diagram will be, this is the crank diagram. The crank diagram will be, look at here. And now we start. Remember the crank diagram just now? You have what? You have force and you have force, yeah? Force, primary. You have force, secondary. We have another one for couple. Also same thing. Primary, secondary. But for couple, this one, for couple, you cannot predict the balance. You cannot predict the balancings. Because why? Because you need to know the magnitudes. The magnitudes. Magnitude is basically the numerical or the value. Yeah. So whatever you've done here is basically what prediction of the balancing of the engine, focusing on force only. Focusing on force for primary and also secondary. It's not couple. Couple, you need to have the numbers or the value or the numericals. Okay, so now primary crank diagram. Start here. Okay, what you have is theta is equal to 90 degrees, isn't it? Okay, so then you construct 90 degrees, all like that. This is your reference. This is the direction we done earlier just now. Number 2, number 3, number 4. Clear. So the second way, and it is balanced, put it here, balance. Polygon you can construct on your own, yeah. For secondary, now secondary force. So 2 theta is equal to 180. Because the earlier part is theta, because we are talking about the primary. When you move to the secondary, it becomes 2 theta. The reason is why, if you look at the equation, F secondary is equal to the mr omega square cos 2 theta divided by n. This is cos theta due to secondary. The primary one, F primary, is equal to the mr omega square cos theta. That is, we have this one. This one will be theta. Okay, so how will be the polygon? Polygon. Same. This one is no longer omega, become 2 omega. Then you have this one, what you done earlier. Cylinder number will be your reference. Now, if you are talking about the fine order just now, 1, 2, 3, 4. So now it's 180. Another, sorry, the the position for each rank will be 180. This one all 180. So if you start with 0, for example, so you will have 180. You will have another 180 is 360. Another 180 will be 540. Isn't it? Yes or no? Yes or no? Yes or no? Yes, anyone? Could anyone else? Thank you. Thank you, Tal. So now, so you will have 180. If Astaghfirullah, it's not 180, yeah. It's not 180, yeah. Astaghfirullah. It is crank number 2. Crank number 3 where will be here. Crank number 3. Crank number 4 will be here. And it is also balanced. So you have F secondary equal to 0. Your F primary also equal to 0. Your summation of F equal to 0. So there is no forces, there's no unbalanced forces acting on the engine. What about couple? We cannot construct couple because you don't have the magnitude. What will be the magnitude? The magnitude will be based on the table that you are going to construct later on. Okay, so let us now, make another one. This one, yeah, this one 4-stroke 1342 4-stroke. Now 4-stroke, put it there. Now 4-stroke, 4-cylinder, of course. Your firing order is 1, 4, 3, 2. Am I correct? Put it there. 1, 3, 4, 2. Sorry, 1, 3, 4, 2. It is 1, 3, 4, 2. It is 1, 3, 4, 2. It is 1, 3, 4. Okay. So now, so the theta, as what we done earlier, is 270 by 4 will give you 180, right? And the firing order is this one. So everyone will be positioned at 180 for primary. So for primary, for example, you can start construct a table. This one is theta. This one is 2 theta. This one be your cylinder. Or put it there, not cylinder. You can put it by firing order. Firing order, put it there, cylinder, firing order. What you have is 1, 3, 4. So 1. For example, let's start at 0. Or everyone will be 80. You have one. You will have 180. Another 180 is 360. Another 360 you will have. You will have what? 540. Isn't it? But for 2 theta you have 0. 180 is another 180 will be twice of 180 is 360. Twice of 360 is 720. Twice of 540 is 1080. Am I correct or not? Or it can also be written as It can also or, yeah, or put it here, or can also be written as this one. This one is a cylinder just now. We find order, of course, theta. This one is 2 theta. This one is 1, 3, 4, 2. It can also be written as 0. This one is 180. This one is 0, is 180. And it can also be written 0, 0, 0, and 0. Am I correct or not? Yes or no? So you can construct at your own convenience. So both are correct. So if I construct polygon now, construct polygon. This what do I have is this one is primary. That's what we've done earlier. Primary crank diagram. Crank diagram. This one for force, yeah. So you will have ZAM right here. Omega is this one. So one is our reference. So the position as what we have here just now, yeah, same position. No, 0 is at the verticals, top verticals, yeah. So you have 1, then we have this one cylinder number 3, then your cylinder number 4, then cylinder number balance, as what we did earlier. Okay, so secondary now, secondary. So put it here. This one is theta is equal to 180. So put it here, secondary um, force. So you have it 2 theta is equal to, now is 180 is 360. So polygon, this is the polygon. This one is 2 omega, cylinder number 1. And if you can go back to this one, we have all zero. So what does it mean? What does it mean? So this is the center one. So we have, this one will be cylinder number 3, 4, and 2, 3, 4, and 2. Because everyone pointing upwards. It is not upward, it basically at 0 degrees. This one at 0 degrees. Understand me or not? Is that clear, class? Hello? Okay, thank you. Yeah, I have what? I have with me 52 candidate or 52 engineer to be. So please respond, yeah? So if you construct polygon, okay, now tell me, it is balanced or not? Does it balance or not? Anyone? This one balance or not balance? Balance or not balance? Balance or not balance, yeah? Balance or not balance again? Anyone?
Balance.
Not balanced. It's not balanced. Yeah, it's not balanced. What? Everything is pointing upward. Well, so what does this mean? So if you construct polygon, you'll be getting all are pointing upward, all are pointing upward, all are pointing upward with the numbers of this one is number 3, the one number 3, number 4, number 2. Isn't it? It is not balanced. So how to balance? You put it away, you bring it to your starting point. Isn't it? It is not balanced. Okay, it is not balanced. Do you understand me? If you have 2 at the top and 2 at the bottom, it is balanced. No, it's not balanced because everyone is pointing upwards, so it's not balanced. So this one, this is the balance force. Balance force. Okay. If supposing you have a crank here, this one, look at here. How to balance the second. If you crank here, so where is your, yeah, here, yeah. So if this crank here, so let's say the crank be pointing that way, yeah, the crank. So you have to put a mass here to balance the system or to balance the engine. Okay, for example, yeah, for example. Any question? Okay, now Okay, I'm going to move to the to the example, another example. This one is not very difficult. I already done this one, so this one is not balanced, pointing upward, not balanced. Okay, this one. So how much it is not balanced? We do not know because we don't have a numbers. Remember what we do have here. We have this one is F secondary, isn't it? F secondary is equal to the the this one is the, it's not the MRD, it's MR omega square. Is the MR omega square. This one is cos 2 by n. This one, what you'll be doing here. This 2 omega is the position. Okay, now let's start another one. This one also I done earlier. I'm not going to do this one. What I intend to share with you to ensure that you everyone is understand is to move to this one. 6 cylinder. After this one, we make 8 cylinder. Today we're going to learn only crank diagram. It's very important to know crank diagram before we start doing the solution. Okay, let's see now. Investigate. They are asking about the investigate because we do not know what will be the magnitudes. Just to say whether it's balanced or not. Investigate the balancing of the internal combustion engine or four-stroke engine with 6 cylinder, of course, with find order of given 1, 5, 3, 6 to 4. Okay, so the position of or the direction will be counterclockwise for your seats. Yeah, I'm going to solve this one. Yeah, I'm going to solve this one. Okay, so now first you this is the option. You can put it in the graph. Sorry, you can put it in the table, or you can also put in the, as I mentioned earlier, this one. Okay, everyone will be, remember, will be 120, 120. Either you can put this one in table, or you can also put in here. Wisely is put in table because you know that where are you basically when you construct a polygon later on. So what I am going to share with you is 6 cylinder, yeah, 6 cylinder, four-stroke engine. Okay, now start with theta equal to 720 because we are dealing with four-stroke engine divided by 6. You'll be getting 120, of course. And the find order given here is 153, if I'm not mistaken. Yeah, the find order given here is, so what is your find order here? The find order given here is 153624. So 153624. So we know that the position for every crank is about 120 for primary. Correct. And you have for 240 for secondary. Because we already understand that secondary is always twice or double of the primary. So if you construct the polygon now, because we are going to investigate now. So you start with what? You start with, of course, your equation is F equal to this one, yeah? Equal to, you have M omega square arm, or I can put it here very, standard equation saying that it's M arm, then omega square cos theta. And we have this one, F, this one summation of S. This one will be F's primary. We have the F secondary, isn't it? But of course, yeah, this one you will. I'm going to simplify this one. Otherwise, it'll be confusing a bit. Put it just one after another. Put it this one F primary, and we have this one F secondary. Isn't it? M R omega square cos 2 theta divided by n. So this one you have primary, this one you have secondary. Okay, then you construct polygon,